In Unit 3, we learned all about the graphs of different linear equations, and in the last topic, we discussed the idea of having a graph of two linear equations that are either parallel or perpendicular. Now, in this unit, we are going to expand on this idea and learn about what is called a system of equations. So, a system of equations defined is a finite collection of two or more equations that share the same variables. So this is what a systems of equations looks like. So we're going to have a linear line, ax plus by equals c, and another linear equation, ax plus by equals c. So we'll have two linear equations with these bracket-like bars, or a bracket-like bar like so. And a, b, and c are all constants like we've seen before in the previous unit when you were graphing with standard form of an equation. So in this section, we're going to just dive into the idea of what systems are and what this means. So when we're solving a system of equations, we're going to have four possible outcomes. That is, you can obtain one solution, many solutions, no solution, or infinite many solutions. Now, I will say in terms of this class and beginning algebra, you aren't going to encounter a system that will have many solutions. You're going to either encounter a system that has one solution, no solution, or infinitely many solutions. You're not going to encounter a system in this class that has many solutions. Or solving a system of equations answers the question, is there a point x, y where both equations are true? Or in other words, when you solve the system of equations or a system of equations, you are finding the point where the two lines intersect. So what does this mean? Well, let's say we have these two linear equations like we have seen here. So let's say the graph of these two linear equations, x, y, looks something like this. Let's say this is the green line is our first linear equation, and then this blue line is our second linear equation. This point right here, where the graphs intersect, that's our solution. So that's the idea. So when you are solving this thing called the systems of equations, you are finding the exact point x comma y where these two lines intersect with one another. Alrighty, so with that being said, let's start by diving into some example problems and see how this plays out. So for example 1, given the system that contains the linear equations y equals 1/2 x plus 2 and y equals x plus 2, find the following. So for part A, we're asked to represent the equations as a system using system notation. So all that means is we're going to take this, notation and write it out in this very specific example that we're given. So I'm going to first start off by writing these curly brackets that we see here. These curly brackets tell us that we're dealing with a system of equations. So whenever you see these curly brackets in math with two lines, that means that you're dealing with a system of equations. And specifically in this example, we have equation 1, which is y equals 1/2 x plus 2. And the other equation, which is y equals x plus 2. And that's it. That's representing here. This represents the system of equations using system notation. Now for part B, we're asked to graph the systems of equations. And I apologize for not having all of this on one page. But I'm just going to, here we are. Just gonna move this. To the other page. There we are. So we're asked to graph the following system of equations, or the following system. So to do that, I'm just going to simply plot an xy plane, the x and y axis. So this is our x-axis, our y-axis, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. Okay, so for our first linear equation, we have y equals 1/2 x plus 2. So I'm going to represent this equation in blue. So our y-intercept is at 2, so we're going to go up here, and our slope is 1/2. So I'm going to go up by 1, and I'm going to go right 2. So we have one right here, and then we're going to go up another and go left, or right by 2, my apologies. And then here, we're going to go down by 1, left by 2, down by 1, left by 2. And this is our first linear equation. Now we're going to have to graph the second linear equation, which is y equals x plus 2. So our y-intercept is the same. It's at 0, 2. And our slope is just 1 this time. So we're going to rise by 1 and go left by 1. Rise by 1, left by 1. Rise by 1, left by 1. And then we're going to, Yes. And then we're going to go down by 1, left by 1, down by 1, left by 1, down by 1, left by 1, down one more. There you go. So, these tick marks are not evenly spaced out, so that's why this doesn't really look quite like a line. It looks more curved, but it's a line. And then for our last part of this, so this is our system of equations graphed. And then for our last part of this example, we're asked to find the solution to the system. Well, recall on the first page, I said that the solution of the system answers the question where these lines intersect. So we're going to have to find the exact point where these lines intersect on the graph. Well, the system looks like these two lines intersect at the y-intercept 0, 2. So that's your solution to the system. Your solution is the y-intercept 0, 2. And that's your answer. Alrighty. So using the same process we did in this first example, I encourage you to pause the video and try example number 2 on your own using the same exact steps. Now, assuming you have given it a go, let's go through this together. So you are given a system that contains the linear equations y equals 2/3 x plus 1 and y plus x equals 1. Now let's find the following. We're going to have to represent the equations as a system by using system notation. So let's first start off by just writing the curly brackets like so. And our first equation is y equals 2/3 x plus 1. And then we also have that second equation, y plus x equals 1. Now, you can also write the systems of equations or the system of equation like so. So you can take this linear equation, and if you want to, you can convert it to slope-intercept form by subtracting x on both sides. So you get y equals 1 minus x. So you could write the system as well like this, if you so prefer. So we'd keep the first equation the same, y equals 2/3 x plus 1. And then the second equation, we'd write it in slope-intercept form. Now, because I like our x variables to line up, especially in systems of equations, I'm going to put this negative x first. So I'm going to say y equals negative x, and since this 1 is positive, I'm going to add 1. And there you go. Now for part B, we're asked to graph the systems or the system of equation. So let's start off by drawing out the x and y axis, x-axis, y-axis. 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. And now, our first linear equation, I'm going to do blue, and our y-intercept is at 1, and our slope is 2/3. So I'm going to go up by 2 and right by 3. And then I'm going to go down by 2, 1, 2, and right or left by 3, 1, 2, 3. So this is what our first line looks like. And then for our second equation, I'm going to do in this yellowish color. And our y-intercept is also at 0, 1, but our slope is -1 this time. So I'm going to be going down 1 and right 1. Down 1, right 1. Down 1, right 1. Down 1, right 1. And I'm going to go up 1, left by 1, up 1, left by 1, up 1, left by 1. And this is your second linear equation. Now, for part C, we're asked to find the solution to the system. Well, it just so happens that this specific solution also happens to be their y-intercept. So our solution to this system is at the point 0, 1.